Okay, so after discuss all the important terms in the hypothesis test, so for today we are going to discuss the steps. All right. So for the steps that we are going to cover, there are two different approaches. So we call it as the first one is critical value approach. Another one will be the p-value approach. Okay. So generally I will teach you both lah. It will be good also if you know both method. And then for critical value approach, right, you will see that in the marking scheme, they actually give you the answer for critical value approach. All right, but sometimes they will provide the value for p-value also. Okay, so to me, I think both are equally important. I think both are useful, so I will teach both. So if possible, you try to learn okay, how to carry out the test by using both methods. All right. Okay, so we'll start with the very first type of hypothesis test first. When we are going to, that is, we are going to test the population mean. Okay, hypothesis test for population mean. All right, so what is the learning outcome here? They will ask you to formulate hypothesis and carry out a test concerning the population mean. Okay, so population mean, I think you should know that the symbol should be mu, right? Okay, in cases where the population is normally distributed. So for the case here, we are going to focus on the normally distributed population with either the known variance or with a large sample. All right, but no matter how, our focus, our main thing is about the population mean. Okay. All right, so to carry out a hypothesis test for a population mean, we actually have a few different cases also lah. All right, but they are having some small differences. Okay, so we will focus on case number one. So case number one, they tell you that the population is normally distributed. Okay, and then after that, the population variance is known. So since the population variance is known, therefore the sample size can be large or can be small. Okay, so this is what we have for the case number one. All these are the characteristics of the condition. All right, the population normal, population variance is known, and the sample can be any size. Because of the population variance is known, and because I should say because of the population is normally distributed, therefore the sample size is not important. It can be large, it can be small. All right. Then when the population is normally distributed, right? Then when we carry out a test, we are going to use the sample mean, okay, to calculate the test statistic. So the sample mean is also normally distributed, okay. And then the test statistic formula is this one. So I think the test statistic formula, if you look at it, you learned it in chapter 4 before in the sampling distribution. So this is a formula when you want to standardize in sample mean, in sampling distribution. All right, so this chapter generally it is something like you need to actually recall back quite a lot of things that you learned before. Okay. All right, so this is all we have for case number one. Now, then I will go into the details now. Okay, so let us have a look for the example 2. So in your notes, you will see that I prepared two columns for you. One is critical value approach, another one is p-value. Here I already hide it. So you can see that there's a p-value approach here. So when you are trying to understand these two methods, right, I would prefer you to try every question or every example for both methods. All right, so that you're familiar with the style, the process, and so on, since it is something new to you. All right, then after you are very familiar with both methods already, then maybe in the exam, then only you choose which one you prefer more, then you just apply. Okay. All right, so here I attach the steps so that you can refer anytime. Okay, if we have a look for example 2, so they are talking about a test of mental ability has been constructed so that for the adult blah blah blah, the test score is normally distributed with this mean and also this standard deviation. So there's a doctor to wish to test whether the sufferer from a particular disease differ in mean from the general population. So they want to test whether a particular disease differ. So differ is a keyword that helps you to form your alternative hypothesis later. Alright, so she chose a random sample of 10 sufferers. So these are the score on the test. Alright, so first of all, if you look at all this, right, I already highlight an important word for you, which is differ. So when you see the word differ, you should know that this is one of the keywords to help you to form the alternative hypothesis. Okay, and then I will also highlight this word for you, normally distributed. Okay, so this is normally distributed, and then that means the population is normal, right? Okay, so this one population is normal. Okay, and then after that, what else? You have the standard deviation 15, and that means the population variance is known. All right, so that's why it belongs to case number 1. All right, so all these are some small details that you can look for before you decide whether is it case 1, case 2, or case 3. Okay, then after that, what they want you to carry out a test at a 5% significance level. So this 5% is the significance level to test whether the sufferer from the disease differ from the general population in the way in which they perform at this test. All right, so this is what we have for the question. Okay, so I think I forget. Oh yeah. Okay, so for critical value approach, so let us start with the critical value approach. So if we are talking about critical value approach, you will see that there are a few steps here. Of course, all the steps here generally in the test, generally we should have all this information. All right, and then you might see that maybe in some of the marking scheme or some of the reference book, the way that they present or the way that they show you the steps will be a bit different, but generally these are the important information that you must include in a test. All right, okay, so for step number 1, you need to have the null and alternative hypothesis, okay, where you already learned it before in the previous video, right? Okay, so we learn how to form the null and alternative hypothesis. Okay, so since they tell you that the population mean is 100 and they want to test whether is it differ, okay, from a particular disease. So what you can do now is you can write out first for the null hypothesis, it is mu equals to 100, and because of the word differ, so you should have mu not equals to 100. Differ so differ you don't know whether it is bigger or smaller, right? It is different only, so it means not equals to. So not equals to, you should put it under the alternative hypothesis. And then for me, again, I will write out a statement which is about the alternative hypothesis. So for me, I will write like this: sufferer from particular disease differ from the general population. Usually we try to copy it from the question. Okay, I try to use the sentence from the question itself. Okay, so this is the a sentence which is about the alternative hypothesis. Okay, then I've done with step number 1. So this one is step number 1. You state the null and alternative hypothesis. Okay, then we proceed to step number 2. So what is step number 2 here? They want you to select a level of significance. So usually this level of significance will be given, okay, in the question itself. So you can see that it is 5%. If in this question they didn't give you any level of significance, then the standard one is 5%. Okay, so just to remind you or just to let you know, the standard one is 5% if let's say they didn't give you. All right, so if the question give you, then you just follow the level that the question want. Okay, so select a level of significance and find the critical value. All right, so now I will proceed to step number 2. Okay, so for step number 2, because your level of significance is alpha, so alpha is 5%, which is 0.05. Okay, so it is 0.05. Then from the normal distribution table, right, you will need to find out the critical value. But before that, you need to decide whether is it one-tailed test or two-tailed test. So for this example, the alternative hypothesis, you see that it is non-equal sign. So non-equal sign means two-tailed test. Alright, so when you're having two-tailed test, I will suggest you to draw a normal the normal graph, the normal diagram. Okay, so that means you have two rejection regions. So remember or not, before that we learned, if let's say you are having two-tailed test, right, you should have two rejection region, one on the right, another one on the left. Okay, and after that, what is the area for this part and what is the area for this part? So this is 0.025. This is also 0.025. Okay, so the center part here will be 0.95. That means when you total up everything, it will become 1. Okay, all right, so what is the critical value? So this is the critical value, Z. So I need to find out this critical value. Okay, so what is this critical value here? So you should look for the table with 0.95 and 0.025. It is a bit similar like what you learn in confidence interval. Do you still remember how to find out the Z? Okay, when you want to have 90% confidence level, all right, so the method is the same. All right, so I'm having 5%. All right, so when I look for the critical value, I should look for the probability of 0.95 plus 0.025, which is 0.975. So if you get the value of Z from the table, you should get 1.96. Okay, so this is the critical value that I have. Therefore, for this value itself, it is also another critical value, but it will be negative 1.96. So 1.6 and negative 1.96 are both critical value for these two-tailed tests. All right, okay. So again, what is the meaning of critical value? It separates the rejection region and also the acceptance region. Okay, all right. So I hope that you roughly have the idea here. Okay, so this is my second step. So I already get the critical value, so I will label it as second step here. Okay, then the third step. So step number 3. Okay, so for step number 3, they want you to identify and also calculate the test statistics. Okay, so for test statistic, when I want to calculate it, I need to have the formula. So formula shown in the note just now is because I'm using sample mean, right? So you're having sample mean minus the population mean divided by standard deviation over square root n. Okay, all right. So now I want to calculate the test statistic. Okay, so to calculate the test statistic, I need sample mean. Okay, so but before I get the before that, when I look at my data, I don't have sample mean yet. So you need to calculate sample mean on your own first. Okay, so what is sample mean? You need to calculate lah. You have the data on top, right, in the question itself. So all these are the data. Okay, so you get the mean from this set of data. Okay, get the mean from this set of data. So for the sample mean, it will be something like 119 plus 131 plus blah 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 until 103, then divided by 10 because it is using a sample with 10 patients, 10 sufferers. Yeah. So divided by 10. So the sample mean that you get for this part is actually 108.5. Okay, then you want to calculate the test statistic. So this is test statistic lah. So test statistic means 108.5 minus your population mean, which is minus 100, divided by population standard deviation, which is 15, over square root n, so square root 10. So from here, you'll get your test statistic, which is 1.792. Okay, so here I've done my step number 3. So step number 3 mainly is for us to calculate the test statistic. Okay, so test statistic is actually a value that you calculate from a sample that you are using, and you want to use this sample to prove whether your hypothesis is true or false. All right, so this is something from the sample. Okay, that means from the data that you collected. All right. Okay, so this is what we have for part number 3, the step number 3. Okay, so for the last step, step number 4. Okay, so for step number 4, they want you to formulate a decision rule, and also maybe I want you to put another sentence here, add in the conclusion. Okay, so how to formulate a decision rule and how to make a conclusion. Okay, so it is very simple. You need this diagram and you also need this Z. All right. Okay, maybe for me, I'm using some other color here to show you. I want to put the value Z 1.792 into my graph here. Okay, so you can see that this critical value is 1.96, right? Okay, so 1.792 should be before 1.96. Okay, so this is 1.792 before 1.96, right? Okay, so now you look at this 1.792. It is in acceptance region or it is in rejection region. So very obvious, it is in acceptance region, right? So since it is in the acceptance region, okay, so what you write here is this one. Okay, so you can write we should accept, we shouldn't say we should accept the null hypothesis, but we will say that we do not reject null hypothesis. So again, I think I told you before also, this diagram, the rejection region and acceptance region, right? Everything is actually about the null hypothesis. So acceptance region means that you accept null hypothesis. Rejection region means that you reject the null hypothesis. So for this test statistic, you see that it is in the acceptance region. All right, but we usually don't say that we accept it, we just say we do not reject it. Okay, so we do not reject the null hypothesis. So this is a decision. This is a decision rule. And what is conclusion? Okay, so because of for those who learn statistics, you may know, okay, what is the meaning of do not reject the null hypothesis. But for those who didn't learn, they might not know what is the meaning of this. So you need to write a sentence or a conclusion to make sure that people know what is the final answer, what is the final decision conclusion for this test. So since you do not reject the null hypothesis, right? So you refer back to the sentence that you write just now. You do not reject the null hypothesis. That means this statement is not accepted, right? Okay, so you need to write a sentence that is opposite to this sentence. So is it any difference or not? Okay, so you can write a conclusion here. Sufferer from particular disease do not differ or does not differ from the general population. Okay, so this is my conclusion. So I will write it out. Conclusion is the sufferer from the particular disease does not differ in mean from general population. Okay, so this is my complete step number 4. All right, okay. So again, because of the test statistics located in the acceptance region, therefore our decision is do not reject the null hypothesis. And after that, you need to put another sentence about the conclusion that you want to make for this test. Okay, so this is step number 4. So some students, if they feel lazy, right, they will ask, can I just write out do not reject? Then I don't want to write the conclusion. So I can tell you for the marking scheme, they will allocate 1 mark for your final step, and this 1 mark have to include this both. Okay, the decision and also the conclusion. So without the conclusion, you might not get the 1 mark. Okay, so usually for a test, a complete test will look something like this, more or less like this. Okay, so usually they will give you the marks based on a few points here. The first one will be they will look at your alternative hypothesis, whether is it correct. That's the first one. Secondly, they usually will give you a mark for the critical value for some of the books or some of the year, the marking scheme. All right, for critical value. Then the third one usually will be the test statistic, and also the last one will be the decision plus conclusion. Okay, so usually they'll give you either 4 to 5 marks. And then you will realize that some of the reference book, they might not suggest you to draw a graph diagram like this. But for me, I do think that it makes me understand better because at least I know where is the rejection, where is the acceptance. So I won't feel confused. So usually I will try to draw it out. All right. Okay, so this is what we have for the very first type, very first complete hypothesis test, which is two-tailed test. Okay, all right, so there are a few steps here that you need to follow. So every time when you try to carry out the test, just make sure that you have all the important points here in your solution. All right,